What is it on the left side? Mode control,
Mode
right?
control, S0 and S1. So what you can see, I have 4:1 mux. For all the 4:1 mux, the select line are connected together with S1 and S0. So the same select line is controlling all the 4:1 mux. You have 4D flip-flop which will be connected in a various fashion, but each D flip-flop is with respect to each mux. So what you can see is output of each mux will go as input of D flip-flop. First connection I have already made, output of mux. This is your output, okay, function. This is your output. So this output is going as input of this D flip-flop. Same way, output of second number mux will also come from the output of second mux. Output will go to second input, second D flip-flop input. Same way, third D flip-flop input will be connected to output of third mux, and same way fourth one will also be connected to the function output of mux. This connection is clear, I guess. Now all the four mux clear is connected together. All the four mux clear is connected together, okay, and it is the active low signal which you already know about it, right? All the 4D flip-flop is connected to active low clear. Now all the 4D flip-flop clock signal is also common. Clock signal is also common and the connection is there. If you draw with me, there will be no confusion. If you are not drawing with me, you will not know from where which wire is coming. So I suggest that all of you should draw along with me. So your clock is connected together. Active low clear is also connected together. I have also given you the connection of select line, which is mode control. Now let us start. Okay, I will give with a different color so that nobody should have any doubt in this. It becomes complicated as I go on. First I will take red color and I am taking the first option, select line as 0 0. If select line is 0 0, it is hold operation. Now what do you mean by hold operation? Hold operation says that whatever input, whatever state of the D flip-flop is there, that is holded. So what do you understand? We understand, you know that S0 and S1 is 0 0 means which input will be connected? You have 4:1 mux. So you will have 4 input, I0, I1, I2, I3 for all the 4. When I select select line as 0 0, your I0 gets connected to the output. So what happens now? I0 is connected to the output. I hope you remember the mux operation. So what is happening? Hold operation. Hold operation means what? Hold operation means I0 will be equal to QA. I0 will be equal to QA. So when I am putting I0 here, so what will happen? I0 part will be connected to QA externally. I0 will be connected to QA externally. Now you should understand what is happening. What you can see, if mode control is 0 0, I0 is equal to F here, and that will go as the input to this D flip-flop, and even if the clock comes, Q will be equal to D. So the input of the D flip-flop through I0 internal connection and output of the D flip-flop through this external connection remains the same. So that is why it goes into hold condition. It goes into hold condition. Why hold condition is so important? Hold condition is important because it will be used for various in between operation of various shift operation. SISO,
Can you
SITO.
explain what I0 is again?
What I0 is?
Can you explain what I0 is?
I0 is your input. See, there are 4 inputs, no? There
Yes,
are
ma'am.
4 inputs of 4:1 mux.
Yes, ma'am.
So I0 is the first input of those 4 input.
Okay.
I will write I1, I2, I3 also with a different color when their turn comes. Okay. So
Yes.
I0 is the first input. I0 of all the 4 mux is the first input. And why I am making first input? Because as of now my mode is 0, 0. 0, 0 means I0 gets connected to output. You all know, no? 4:1 mux operation. So now the same way I need to show the connection of second mux I naught, and I hope you would have guessed by now that this will be connected to the output of second D flip flop. Why? Because I need to maintain this hold operation for all the mux. I need to maintain this hold operation for all the mux. So QA, QB, QC are externally connected to I naught of all the 4 mux. So complete this connection now. This is only hold operation. We have completed only 1/4 of the circuit. Is this part clear? Can I go to the second option? Second option will be shift right. Okay. So I will make second option 0, 1, and this is shift right. Shift right. Okay. Now you all know what do you mean by shift right? Shift right is a data is provided towards the left hand and it will be shifting right. So when I provide the data left hand, it should be available at left hand of the circuit. So I will show here I1. I1 is my second input of 4:1 mux, and this I1 will be the data in for shift right operation. SIR means serial input for shift right. Okay. SIR means serial input for shift right. Serial input for shift right. That is SIR. Now what do you want? You want this input, whatever 1 bit input will come here, that should move towards right. You have seen what is the meaning of shift right operation yesterday. Whatever data 1 bit we put here, that should go to QA, then QB, then QC, then QD. Right? This is what is shift right operation. Now you see the connection now. What will happen when I am making the mode control as 0, 1 now? For all the mux, your I1 is connected to the F. All the 4 mux, I1 is connected to the output of the mux F when mode is 0, 1. So now I have to see how the connection will happen. Now you know that a data input is provided here. Because mode is 0, 1, this I1 will go to F, right? And your data, what is provided here, 1 bit data, from this it will go as the input to D, and it will be available in the next clock cycle at QA. Now what do you want? This QA should go to QB, but it will not go directly the way it was going yesterday. Now it is through universal shift register. So what will happen? This QA, the data input will go from SIR to F of first mux to D of first flip flop to Q of first flip flop to QA, and this QA will be connected now to I1. Okay, so this is the connection. It will be connected to I1. So now the same way output of QB will be connected to I1 of next mux. Okay, so now you can see how the connection is changing. It will go and connect to I1 here. Same way QC will be connecting to I1 here. And where you will get your data out? You will get your data out at QD. You will serial out will happen here. So see the flow of data. If I have put that bit here and mode control is 0, 1, see my mouse where it is going. Data went to this blue color SIR, 1 bit data. Mode control is 0, 1 for all. So everywhere I1 is connected to F. So data bit is here to I1, to F, to D, to QA, down to I1. Again, this will be going to F, and then it will go to QB. Same way, it will come down to I1 of third mux, go to D, QC, come down, go to I1 and go to QD. So this is how the data will flow serially, right? From the mux to D flip-flop to the mux to D flip-flop. Like that, the data will be flowing to QA, QB, QC, QD. So this is your second operation of shift right. I hope it is clear to all of you. If any doubt, please ask me. Okay, next we will go to third operation, that is shift left. If I bring shift left, by this time you should have understood what is happening. Now shift left means data should be given to right hand side. So now you know that 10 means mode control says that third input is selected for all the 3 mux. So I am talking about the third input now. Sorry, third input is called as I2. So I will take my third input for all the mux. And you all must have understood by now is my SIL is what? Shift input, serial input for left shift. SIL. I'm not writing it now. You people can write on your own. It is serial input for shift left. Serial input for shift left. Okay. So now you will have your this operation. So now your data is given at I2. Mode control is connecting I2 to F, but the data should go towards left. Now data should go towards left means what? You can see the connection now. I2, my data, my bit has gone. F is equal to I2 now, that 1 bit data, and it is available at QD now, right? It is available at QD now. But where it will go? Where it will go? It will go to I2 of the previous second last mux, means this one. So now you see the connection. Whatever QD is there, that QD should go and connect to I2. All of you see here from where I have connected. QD should connect to I2. So QD is here. See my mouse cursor. QD is here. The connection is given to I2. Same way, now this I2 data will go to F. Why? Because select lines are 1, 0. And then you will have your data in here. And then QC will get your data. Now this should go to I2 now. So you know the connection now. This will be QC will be connected to I2 of previous mux. Same way, now this data I2 will go to this QB, and QB data is available, and this QB should go to I2 of the first mux now. So now I will get this connection, QB to I2. And then what will happen? Your data will reach I2 and F, and data out will happen from QA. So when you are doing serial in right for shift right, the data is entered at blue SIR and data is finally available at QD. When you are doing shift left operation, data is being fed at SIL and data will be available at QA. So you can see how shift right and shift left has happened. Okay, now the last one, parallel load. Yesterday you saw, na, what do you mean by parallel in? Parallel in says that all the 4 bit of data appears at the output at once in 1 clock cycle only. So the last one will be your parallel load. Last one will be your parallel load, and I will take it as this color, parallel load, and I hope you people can understand the connection on your own now. So parallel load means this I1 and I2 is used for shift left and shift right only, but we need the parallel input also. So parallel input It is being taken care by I3. So I3 parallel input, IA will be given, I3 parallel input, IB will be given, and so on.
Can you stop for 2 minutes? We'll just copy this.
Okay, fine.
That's fine.
ID. Okay, I will hold it for some time after stopping the recording. Okay. So this parallel input IA, IB, IC, ID is given. Now when the mode control is 1, 1, select line is 1, 1, parallel load, what will happen? I3 will get connected to function F, right? So what will happen? If mode control is 1, 1, IA, IB, IC, ID will get connected to output of all these mux, right? And when the clock cycle 1 comes, all the input of this D will be available at QA, QB, QC, QD. The circuit is complete actually. Okay. Now I will just show you all the 4 or 5 types of operation. Okay. Now let me complete
Can
it.
you explain the parallel load again?
I will explain. See, parallel load means your data should be available at once. So parallel load is now written in this brown color. This is my parallel input. So parallel load means my 4-bit data is available here. I will make my 4-bit data available here, and I will make the mode control as 1, 1. Then what will happen? S0 and S1 is 1, 1 means I3 gets connected to this F of the 4 mux. So IA will reach this F, IB will reach this F, IC will reach this F, and ID will reach this F. So with mode control 1, 1, all IA, IB, IC, and ID will be available at the output of all the 4 mux. So this is called data loading. Data is made available at input of D flip-flop. So data load only has happened. Still parallel out has not happened. For parallel out, what will happen? The clock will be made high or it will be enabled. That time Q will become equal to IA, means QA will become equal to IA, QB will become equal to IB, QC equal to IC, and QD equal to ID. So parallel input will come, mode control will shift it to the output of mux, and clock equal to 1 will make it available at QA, QB, QC, QD. What I explained just now to you is parallel in, parallel out. Serial in, serial out, I explained along with the circuit where the data is moving from mux to D to mux to D to mux to D, and it is available at the right hand side. Serial in, serial out towards the left direction was through the green I2, and again it was 2 mux to D flip-flop, back to previous mux to D flip-flop, back to previous mux, and so on. You are getting your data at QA. Now what do you mean by serial in, parallel out? Serial in, parallel out, what happens? In serial in, parallel out, if it is serial in, parallel out from left direction, for 3 clock cycles, your data will be available from input. So when input you are giving 1-bit data, I will show you here. If input you are giving 1-bit data, that will be available at QA. Then you give your next bit data. By the time QA would have shifted to QB, and this 0 would have gone to QA. You give your 3rd bit data, that will reach your up till QC. You give your 4th bit data, it will reach up to QA. So when your serial input of 1011 is available at QA, QB, QC, QD, and that moment, if you are taking your output, it is called as parallel out. Then it will become serial input from left direction to parallel out. The same thing if I do with this green color I2, if I start feeding in the data from the right side towards left, just like this 1011 will start feeding from SIL, and by the 4th clock cycle, all the data will be available at QA, QB, QC, QD. And if you take the data at that 5th clock cycle, it is called as serial in left, parallel out. I hope it is clear. If I do not take data at 5th cycle, then it will become serial in, serial out in whichever direction, but data will be available only after 8th clock cycle, because the data is coming one by one in a queue, it is coming, right? So this is how this universal shift register is taking care of all the possible operations. Now you have a block diagram of the serial in, block diagram of universal shift register. Quickly I will make, because the material is still not uploaded in GCR. I will make it here, you people copy it. This is universal shift register. You have your 4 output, and what is that 4 output? It is QA, QB, QC and QD. Your 4 output is there. Okay, you have your 2 select line, but you know that your select line is common, so I will give connection only to S1, S1 and S0. Only 2 input, because all the mux select lines are made common. So you have your 2 select line. Now you have your serial in left, which you saw in the circuit. You also had your serial in right, which you saw in the circuit. And you also had the facility of parallel load. So the parallel load facility is also given with your IA, IB, IC, ID. Whatever you see in the circuit should be seen in the block diagram also. So you have your IA, IB, IC, ID. You also saw that a same clock was governing your all the D flip flops. So I will have only one clock signal. I will have only one clock signal. And last, what did you see? You also saw that there is one clear input, active low clear input. So this is the block diagram of your universal shift register, which is available in an IC form in the market. Okay. So this is all about your universal shift register. If you have any further doubt, you can ask me.
Can you show the IC again?
Yes, I will show.